Hello people, this is Dennis, and today we're gonna build a correlation coefficient database with Excel. So when we say correlation coefficient, it is the strength of the relationship between two sets of variables. So for instance, what we're gonna build today is phone calls and sales. So we have a sales rep. He makes probably 10 calls and make 10 sales. Another one make 5 calls, make 20, make 3 sales. So the relationship between the call and the sale. So what is correlation coefficient? So the strength of the relationship between two set of variables, and in this case calls and sales. So correlation is graded from -1 to +1, and over here we have 0. So if we do the correlation coefficient for this and we get, for instance, -1, that is, we have negative strong correlation. And if we get +1, then we have positive strong correlation. If we get 0, that means there is no correlation. If we get +1, that means it's easy to predict our cell. Easy to predict. Same here. If we get -1, it's also easy to predict. You're gonna see here in a minute. And if we get in between here, let's say 0.5, -5, that is the average between 0 and -1. It's not easy to predict if we don't have the strongest negative. And also if we get in between here, let's say 0.7, is also not easy so to predict. So if our correlation falls between -1 and 1, it becomes easy to predict this correlation. So this is what we're gonna be talking about. First, let's get rid of this and let's choose this. we're gonna build this correlation so that we use it for prediction. So first we're gonna have our sales rep. You're gonna have sales rep A, B, C, D, E, F, G, H, I, and J. And the sales rep is gonna make calls. We call the call X value, and when he makes the calls, we're gonna see if he's gonna to be able to convince the customer to make a sale. So the sales, and we call this Y. So this is our variables X and Y. So first we're gonna be calculate 20, 40, 20, 30, 10, 10, 20, 20, 20, and 30. Then this, he made 20 calls, then he made 30 sales. Make 40 calls, make 60 sales, and 40, 60, 30, 40, 40, 50, 30, and 70. So after this, we're gonna do more calculation, and this is called the actual value. So this actual value is gonna help us predict, and we will see how far we will come close to this prediction. So we're gonna do a little bit more calculation, and over here I'm gonna erase down here, and we're gonna have the sum of this. We're gonna have the average, we're gonna have the standard deviation, and now we're gonna have the count. So with all this up to, we had 10 counts. The sum will be 220, the average 22, and the standard deviation 9.19. Over here, get 450, 45 average, 14.34, then the count is also 10. And over here, x minus x bar, we call this the average is in this case is x bar right here, in this case is y bar. So you take this 20 minus the 22, you end up with -2. So you do the same thing here, and y minus y bar. You do the same, and now we're gonna take our x minus x bar times y minus y bar, and that's gonna help us calculate our correlation coefficient. Then we will come up with the predicted value, and we will see how close we will come to this. And lastly, let me clean this up. We will have our predicted value right here, and we will have our error or deviation. That is actual minus predicted, right? So that will go here. So with this being said, let me give you the formula for correlation coefficient and another one for regression, and we're gonna use that for the prediction over here. Yes, delete. So correlation coefficient formula is the sum of x minus x bar times y minus y bar divided by n minus 1 times the standard deviation of x and the standard deviation of y. So once we get this, it will give us a number, which is the correlation. It's equal to a number. It's gonna be within -1 to +1. Remember, when it is -1, is strong negative correlation. When it's +1, is positive strong correlation. Then we will use our regression equation, which is equal to a plus bx, to come up with the predicted value, which is right here, y hat. This is called y hat, and we're gonna define these variables. First, we're going to define a is equal to y bar. This is the average of y minus b times x bar. So this is called the y-intercept. Y-intercept, or the initial value. That is, if we don't make no calls, if this is equal to 0, what is the value? Is the value of y when x is equal to 0. In this case, if we make 0 calls, how much cells are we going to make? So, and the a the B calculation is the regression coefficient, which is the number we will get here, times standard deviation of y divided by standard deviation of x. So, and this is the slope. That's the slope. That is each one increase of x, how much are we adding? To our, so let's say if we make let's say here is 0 and here is plus, and our B, which is the slope, if we have 1 and we make 0 cos, that means our y is equal to 0. If we make 1 cos over here times 1, which is equal to 1. So this is the increase, our slope, our constant. In this case, right here, how much are we adding with each additional increase of cell? Sorry, each additional increase of cos, how much are we adding? In this case, if we add 1, it becomes so easy to predict, because, and if we get 2 times, if we have 1 here and we make 2 cos, that means we get 2. So if our correlation coefficient is +1, the prediction is easy to predict. So let's go into Microsoft Excel and build this database so you can see what I'm talking about. So first of all, let's name this sales rep and give them sales rep A, B, C, no, nope, you gotta type. Let's name here 1. Let's use numbers instead of letters. 1, 2, 3, 2, 3, 3. Cut and go to 10. Let's name here calls, name here X, let's make this capital calls X, make this cells, and make call here Y, and our numbers 20, 40, 20, 30, 10, 10, 20, 20, 20, and 30. So we don't need this. And here to make 30, 60, 40, 60, 30, 40, 40, 50, 30, and 70. And let's name here sum, average, standard deviation, and the count. So equal to sum, we copy this cell and copy it that way, and it's equal to average, and go this way.